Just to recap as to what an antiderivative, yes.
Just real quick, so do we not have to do the homework for 5.3 then?
No.
Okay, thank you.
I got rid of it.
Okay.
Just as a recap for antiderivatives, based on the video, we call it an integral. But what is the purpose if you have a function, say, that is what we call an integral. What is the purpose? If we integrate this, there is a simple rule called the power rule. The integral of x squared dx is x cubed over, oops, sorry. Let me find it first. So if we simply have x squared, we just have to add 1 to the power and divide it by n plus 1. It's just the reverse of what we did with derivatives. You subtract 1 from the power, multiply by n minus 1 here. You add 1 to the power and you divide by n plus 1. So that would be x cubed over 3 plus c. Why do we call it an antiderivative? So if I took the derivative of the answer, what is the derivative of x cubed?
2x.
2x.
Wait, did you say derivative?
Derivative of x cubed.
2x. Oh, 3x.
3x.
3x squared over 3. What is the derivative of that constant?
0.
0. The 3's would go away, and you would simply have x squared. And what does that correspond to? That is simply the function you have over there, right? And which is why we call it the antiderivative. But, what do we mean by antiderivative? It's integral. So the key thing to note is that power rule. The c over here is the constant of integration. We call the integral that you see as an indefinite integral. Why do we call it an indefinite integral? Couple of reasons. Well, the answer is in terms of x. So I could put any value I want to put for x, and I'm going to get a different answer. So how many possible values of x would we have? Indefinitely many, right? And it's one reason why we call it an indefinite integral. Another reason is, well, if you said, oh, I don't want to change the x at all, you still got that constant, right? So I could put any number for that constant. Give me one number.
1.
1, okay. So possible answers. Okay. Another constant.
5.
5. Another constant.
3.
3. No one wants to be negative or fractional. Right? So I kept changing the values of c, and I keep getting different answers. But here is the catch. No matter which answer you pick, and if I differentiate it, I'm going to get the same x squared. Do you agree? Yes? So you don't just have a solution, you have a family of solutions. By changing the value of the constant, you could keep on coming up with solutions, which is why we call this integral an indefinite integral. Does that make sense? Okay. So, as I mentioned, we have infinitely many solutions, but I could simply look at a single solution if I impose a condition, correct? I could say, oh, the function has to satisfy this one particular condition, and if it did, then there could only be one answer. Do you agree with me? Yes. And that one answer is what we call a particular solution because it is particular to one condition. So, I'm going to erase, I have a problem here. So if you want more details about antiderivatives, do look up the video that I've posted. Another reason as to why we call the antiderivative, because f prime of x, when you integrate it, would become f of x, and that would become the antiderivative. So how do we go about solving this problem? So that right there is the condition that we need to satisfy. So I'm putting a restriction, so that is a condition. Now we just have to integrate. Just like derivatives, you can distribute the integral into the expression and take the integral of each term. And earlier, I wrote the power rule. What is the value of n? 3. So we add 1 to the 3. We divide by n plus 1. I get 4. What is the power of x in the second term?
1.
1. Add 1. 1 plus 1 would be 2. Divide by 2. Integral of a constant is always x. Of course, if you took the derivative, you get 1. I like to save my work till the very last, save my work and just throw in the constant at the very last step. You don't have to carry that constant with every step. Of course, this is an easy integral. So that is my constant of integration. And at this particular point, this is the indefinite integral. Yep.
And there's also, is there usually a way to check if the answer is correct as well?
Yeah, if you took the derivative of this, it should equal that.
Oh, perfect.
That's a good question. You can always verify your answer just by taking the derivative of your answer. The derivative of the answer must match the function that you started with, and the full in this case. So how do we solve for the constant? We need a particular solution. So the integral of f prime of x dx is f of x plus c, which is another reason as to why we call it the antiderivative. You took the derivative here, the integral gets applied, the derivative gets cancelled out, you get the original function, hence the antiderivative part. So what do we know? We know 3x raised 4. That is the function that we found. So the function is equal to f of x, the antiderivative. And what else do we know? The condition is f of 0 must be 2. So I'm going to plug in 0 for x. Which would mean 3 multiplied by 0 raised 4 over 4, 7 0 squared over 2, plus 0 plus c.
And then that would equal to, right? It would equal to? Right?
Yes.
Okay.
So all the zeros, these three terms would be 0. So you simply end up having f of 0. But what is f of 0? It is given in the problem that f is 2. So you found the constant. So you have one particular solution. What is that particular solution? The function that you found, so 3x raised 4 over 4 plus 7x squared over 2 plus x plus 2. Does that make sense? Do we follow? Can I have these? What is the condition here? 1. F of 1 is negative 1. And we do have to put a restriction here. X has to be bigger than 0. If x is 0, then that derivative will not exist. So the very first step is to find the integral. So integral f prime of x dx. Right? So we've got to use power rule, and we can do it. So if I move x cubed from the denominator to the numerator, what would happen to that 3? If x cubed moves from the denominator to the numerator.
X to regular negative 3.
X raised negative 3. And that resembles what we did the previous problem. what is the power here? The power is -3. So when you integrate it, you add 1 and you divide by -3 plus 1. -3 plus 1 is -2. Divided by -2 minus 2. The power here is 1, so x raised 1 plus 1 would be 2, divide by 2. Yes? That would go away, and what do we have? We have x raised -2 over -2 minus x squared plus c. As I said, I proved that constant at the very last step. We now have a condition. The condition is f of 1 would be -1. So we have the function sorry. All we have to do is plug in 1. One raised to any power is just 1, so we have 1 over -2. -1 plus c. 1 over -2 is the same as -1/2. -1 plus c. -1, -1/2 is -3 over 2. What would that equal to? That would equal to -1. And why is that? Because that is our original function or condition. F of 1 is -1. Move the 3 over 2 to the other side, so we have -1 plus 3 over 2. 3 over 2 is 1.5. If you have 1.5 and you take away 1, you're left with half. So the value of the constant is 1/2. So what is the particular solution? So right here. Are we clear? I'm going to let you try this one. So the key to solving this problem is to rewrite square root of x as x raised to the power of something. How could you write that? Square root of x as x raised to the power of something. What should the power be?
Isn't it 1/2?
Is it?
Yeah.
Okay. So if you rewrite this would simply be x raised 1/2 plus x squared plus 1. So go ahead and integrate it. Let's see if we can do it. So we've got to integrate that through integral. The power here is 1/2. So you add 1. 1 plus 1/2 is 3/2. You divide it by 3/2. The power in the next term is 2. Add 1 to the power, so you have 3, divided by 3. The integral of 1 is just x. And you have plus c. You can leave it as is, or you can take this fraction. If it moves to the numerator, you've just got to flip and multiply. So that would end up being yes. Now we have to plug in the value 4. If I plug in 4, f prime of 4 would equal to 2/3, 4 raised 3/2, plus 4 raised 3/3, plus 4, plus c. You can use your calculator. 4 raised 3/2 is 8. 4 cubed over 3 is 64/3. Plus 4 plus c. We want to combine these two, they have a common denominator. So I could simply add the numerators. So 64 plus 16 would be 80 divided by 3 plus 4. I need a common denominator here. So multiply and divide by 3. 4 times 3 is 12. I get 12/3. So c plus 92/3 would be equal to f prime of 4, which is 0, given in the problem. So what is c? C would then be negative 92/3. So what is the particular solution? Are we clear? So I want you to tell me what the difference is between the problem that I'm about to write and the one that we just did. Can you spot the difference?
You just wrote a second derivative.
We have a second derivative, right? The last problem we had the first derivative, And to solve that, we needed one condition. Now we have a second derivative, so you would need two conditions. Does that make sense, or else you can't solve? So the key idea here is if you have f double prime of x, you integrate it once. You will get f prime of x, integrate it again. And you will get f of x. In the previous problem, we just did that part. Or previous problems, I'd rather say. So that's all we did. We just have one extra step. So the first step is to go from f double prime of x to f prime of x. So the second derivative of x dx would be equal to f prime of x plus c. So we need to find f prime. How do we find f prime? Well, we have to integrate that. If you have a constant multiplied to x, you can pull the constant out. What is the power of x? 1. So that would become two x raised to over 2. Yes. The 2's would go away. And we have x squared. And I like to throw that constant at the very last step. I'll call that constant C1. Why am I calling it C1? Because I know that there are two constants. One in this step, one in the subsequent step. So we've got to solve for C1 first before we can move further. So what is C1? Well, we know f prime of 0 is 1. And we just found f prime of x. F prime of x is x squared plus C1. So 0 squared plus C1 would equal 1. Agreed, because f prime of x is x squared plus C1. That means C1 is simply 1. So what is f prime of x? It is simply x squared plus 1. It's the same from here on out because we're doing that part, and that is something we did earlier in the previous problems. So if I integrate f prime of x, I'd end up getting f of x. So integral f prime of x dx is simply f of x. So we found f prime of x. We have to integrate. What is the power here? It is 2. So if we integrate it, we have x cubed over 3 plus the integral of x is simply, integral of 1 is just x plus c I'll call it C2, because, it's the second constant. You can call the constant whatever you want. You could call it A, B. It's entirely up to you. So the function is equal to x cubed divided by 3 plus x plus C2. Do we have another condition to find C2? Yes. F of 0 is 2. So if I plug in 0 here, get 0 cubed over 3 plus 0 plus C2 would equal F of 0. What is F of 0? 2. So C2 is 2. So what is the particular solution? The function that we found, which is x cubed over 3 plus x plus 2, and that's it. Good. No, great. So the second derivative of a function f of x is x plus square root of x. And we have two conditions because what we have is a second derivative. The first condition is f prime of 0 is equal to 1. The second is f of 0 is equal to 1. Same process. You have to integrate the second derivative to get the first derivative. Integrate the first derivative to get the function itself, and you make use of the two initial conditions, in this case initial conditions, to find the constant c. How do we find the first derivative? We integrate the second derivative. We have x plus square root of x, and anytime you have square root of x, what should you do?
Flip it to the
Convert it to an exponent. Now the power there is 1, so we've got x squared over 2 plus x raised 1/2, and you just have to do 1/2 plus 1. 1/2 plus 1 is 3 over 2, divided by 3 over 2. Flip and multiply, you have 2 over 3, x raised 3 over 2. I'm going to throw in the constant at the very last step, so let me call it C1. We're going to make use of the very first condition, which is f prime of 0 is equal to 1. So plugging in 0 for x, we have f prime of 0, which is equal to 1. So 1, all of that is 0, would equal to C1. So what is our first derivative which satisfies the condition? The first derivative is simply the function we found. So the value of C1, 1. And now we've got to go to the next step where we find f of x. How do we find f of x? We integrate the first derivative to get the function f of x. So f of x is equal to integral f prime of x dx. We found f prime of x already, so we're going to put that in here. We already have 1/2, so I'm going to keep that's 1/2. X raised to the power is 2, so you add 1 to 2, you get x cubed divided by 3 plus 2/3. The power is 3 over 2. 3 over 2 plus 1 is 5 over 2. X raised 5 over 2 over 5 over 2. The integral of 1 is just x. Let's simplify this prior to going to the next step. Again, I like to throw in the constant at the very last step. So x cubed divided by 6 plus 2 over 3. Flip and multiply, you get 2 over 5. X raised 5 over 2 plus x, which would give us x cubed over 6 plus 4 over 15, x raised 5 over 2 plus x plus c2. And that would equal to f of x. And how do we find the value of C2? We use the last condition, which is f of 0 is equal to 1. Since f of 0 is equal to 1, plug in 0. 0 cubed over 6 plus 4 over 15 multiplied by 0 raised 5 over 2. X is 0 plus C2. And what is the value of f of 0? It is 1. And everything here in sum is going to become 0. So 0 plus C2, which would imply C2 is just 1. Good. So what is the particular solution? The particular solution is simply that term, or those terms, plus 1. So, I guess I'll write it. Are we clear? So, key takeaway. I've seen students not find the value of the constant at the very first step or completely ignore it and go to the last step. If you have a second derivative, you have to find the constant for the first derivative and then the constant for the function. If you have a second derivative, it's a differential equation, so if you have an equation with a second derivative, then you need two conditions to solve. There is a question, what would you get if I integrated the third derivative? Look at what I wrote here.
The second derivative?
You'll get the second derivative. And then the process is the same. But as far as this class is concerned, we're not going to exceed the second derivative. Does that make sense? So we can keep on going, first derivative, integrated to get the third, integrated to get the second, integrated to get the first, integrated to get f. So if we have three derivatives, then we need three conditions. If we have four derivatives, then we need four conditions.
Wouldn't you get the same constant as well?
Not necessarily. That would depend on the condition that we used.
So the condition's not universal for like different derivatives?
That is correct.
Okay.
I mean, you can't have the same, depending on the process, the value of the condition will change. Does that make sense?
Yeah.
Now, I do have to point out something. I've plugged in arbitrary values to find the function. I didn't plug in the exact values of the function. I picked arbitrary values. So some of the conditions may not be satisfied, or yeah, it will probably be satisfied. Yeah, it should work out. Good? Okay, we'll stop right there.